If you are about to spend $300 on a new cordless drill this weekend, you are not buying a power tool. You are buying a subscription to a battery platform, and the first bill comes due in about 2 years. A 2-pack of Makita 18-volt batteries costs $178. A DeWalt DCF840 impact driver costs $159. The batteries cost more than the tool they power. That math is not an accident, it is the business model. Once you own the batteries, you buy more tools on that platform. Once the platform owns your garage, replacing a dead pack costs as much as switching brands entirely. Repair technicians have been warning about this for years. The gearbox housing switched from aluminum to plastic that traps heat and warps under load. The circuits are potted in resin so you cannot fix them, and the batteries contain authentication chips that can reject third-party replacements. Today I am naming the component downgrades, exposing the thermal traps, and giving you the 3 buying rules that sidestep the entire scam, including one brand whose warranty structure makes every Home Depot option look like a money pit. A 2-pack of Makita 18-volt batteries costs $178. A DeWalt DCF840 impact driver, the tool itself, costs $159. The batteries cost more than the machine they power. And that math is not an accident, it is the business model. You walk into Home Depot thinking you are buying a power tool. You are not. You are buying a subscription to a battery platform. The tool is the free sample. The recurring charge is the pack you will replace in 2 years when the cells degrade, the protection circuit trips, and the trigger does nothing. The brands you trust, DeWalt, Milwaukee, Makita, have re-engineered their products around one simple principle: make the consumable expensive, make the consumable unavoidable, and make the consumable fail on schedule. Today we are going to open the gearbox, trace the heat path, and show you exactly what changed inside modern cordless tools. We will name the component downgrades, expose the thermal traps, and walk you through the battery lockout systems that can brick a perfectly good tool. Then we will give you the 3 buying strategies that sidestep the entire scam, including one warranty structure that makes every big box brand look like a money pit. Here is what happened. In 2005, Makita launched LXT, the first 18-volt lithium-ion cordless tool system. That platform created the modern cordless category. It also created the modern cordless business model. Once you buy batteries, you buy more tools on that platform. Once the platform owns your garage, replacing a single battery pack costs as much as switching brands entirely. The battery became the lock-in device, but the real engineering shift happened inside the tool body. Older corded drills use brush motors with carbon brushes that wore down over time. That sounds like a flaw. It was actually a feature. Brushes are a 10-minute, $10 repair you can do on your kitchen table. A repair guide for the Milwaukee 024-0-2 corded drill walks you through it step by step. Pull the cap, swap the brushes, reassemble. The motor keeps running for another decade. Modern cordless tools use brushless motors, no carbon brushes to replace. Sounds like an upgrade. Here is what they do not tell you. Brushless motors require electronic commutation. The motor cannot spin without a controller. That controller is now soldered to a circuit board, and in many tools, that board is potted, encased in resin, so you cannot repair individual components. A teardown of the DeWalt DCF840 impact driver shows exactly this: a potted circuit labeled in the housing. When that circuit fails, you are not replacing a component, you are replacing a module or a tool. The second downgrade is the gearbox housing. Makita markets the DHP484 drill with a specific bullet point: aluminum gear housing, and all metal gear construction for extra high transmission durability. That phrasing exists because Makita knows you need to hear it, because other models like the DHP 485 use a polymer gearbox housing. The service manual shows it clearly. White plastic structural components holding the gear assembly. Same brand, same battery platform, different survival odds under heat, and heat is the killer. Nylon 6, a common engineering plastic and tool housings, has a thermal conductivity of 0.23 watts per meter Kelvin. Aluminum alloys run around 225. That is 1,000 to 1 difference in how fast heat moves through the material. When you run a plastic house tool under sustained load, the heat generated in the gears and motor stays where it is generated. The plastic cannot conduct it away. It soaks, it softens, it deforms. Nylon's glass transition temperature, the point where it starts losing stiffness, is around 53 degrees Celsius. A tool under heavy load can hit that in minutes. This is not a cost-saving accident. This is a calculated trade-off. Plastic is lighter, quieter, cheaper to mold, but it also fails faster. Fails in ways you cannot see until the gearbox geometry drifts, and fails in ways that push you toward replacement instead of repair. Now let me show you exactly how these design choices turn into repair bills. The first failure is thermal throttling and gear softening. You are driving lag bolts into pressure-treated lumber. The motor pulls hard. Heat builds in the gear mesh. In a metal housing, that heat conducts outward into the shell, dissipates into the air in your hand. In a polymer housing, the heat concentrates at the gear teeth. Research on polymer gear failure from IIT Madras describes exactly what happens next. Prolonged high temperature softens the material, leading to plastic deformation and tooth distortion. The teeth do not snap, they round off. They deform. Backlash grows. Torque transfer drops. The tool feels tired before anything visibly breaks. You cannot point to a failed part. You just know the tool is not what it was. The second failure is dimensional creep. Polymer does not just soften under heat, it drifts under sustained load. Creep is time-dependent strain, and it accelerates with temperature. Studies on polyamide materials show measurable deformation at 60 degrees Celsius. Moisture makes it worse. A Perkin-Elmer application note demonstrates that absorbed water plasticizes nylon, pushing its glass transition behavior lower. Your gearbox housing slowly changes shape. The gear shafts move out of alignment by fractions of a millimeter. That is enough. Wear accelerates, noise increases, efficiency drops. And the fix is not a new gear, it is a new gearbox assembly. Makita lists that part at 33 pounds, 60 for the DHP 485 series. Before labor, before diagnosis, before shipping. The third failure is the controller becoming a replacement module. Remember that potted circuit in the DeWalt teardown. When vibration, heat cycling, or a voltage spike kills a component on that board, you are not desoldering a MOSFET. You are ordering a new controller. Makita lists the controller for the DHP 485 series at 55 pounds 20. That is the part. A shop will charge you labor on top. For context, a Milwaukee 024, 0-2, 0 corded drill. The whole tool costs $82.99. The replacement brain for one cordless drill costs nearly as much as an entire corded tool that you can fix yourself. The fourth failure is battery lockout. Modern lithium packs are not dumb power sources. They contain battery management systems that monitor cell voltage, current, and temperature. Texas Instruments documentation for power tool battery packs describes the architecture. Monitoring circuits, control charge, and discharge MOSFETs. When the pack detects a fault, over discharge, over temperature, cell imbalance, it opens those switches. The pack stops delivering power. Makita calls their version Star Protection, real-time data exchange between tool and battery to protect against overloading, over-discharging, and overheating. That is a safety feature. It is also the mechanism that makes your battery dead while the cells still hold charge. The protection circuit tripped. Recovery requires equipment most owners do not have. Replacement costs $89 per pack. The fifth failure is the one that makes this a system, not a series of accidents. Battery authentication. Patents exist directly from major manufacturers describing tool-to-battery authentication. A microchip application note walks through the design. The tool sends an inquiry to an authentication component in the battery. If authentication fails, the tool limits operation or removes power entirely. One patent describes disabling tool operation after a phase-out period or cycle limit when authentication is invalid. This is the architecture for rejecting third-party packs, rejecting refurbished packs, rejecting cells you rebuilt yourself. Even if the lithium is healthy, even if the pack has capacity, the firmware says no, and you are back at the store buying OEM batteries that cost more than the tool. Quick question before I show you what to buy instead. Open your tool bag and count. How many dead batteries do you have sitting next to tools that still work? 1, 3, 5? Drop the number in the comments because that pile of good tools with dead packs is the entire business model. Here is how you get out. Number 3. For any task where you do not need to move, buy the corded version and skip the battery trap entirely. The Milwaukee 0240-20 corded drill costs $82.99. No battery, no platform, no authentication chip. The motor uses carbon brushes, a wear item that costs a few dollars and takes 10 minutes to swap. You pull the cap, slide out the old brushes, slide in the new ones, and the drill runs for another decade. The trade-off is the cord. You are tethered to an outlet. You cannot take it up a ladder as easily. But the math is simple. $83 once, plus occasional brushes, versus a cordless tool where the battery replacements alone will outrun that cost within 2 cycles. For bench work, for shop work, for any job within extension cord reach, corded tools are not a compromise. They are an exit ramp. Number 2, if you need cordless, buy the version with metal internals, and the manufacturer will tell you which one that is. Makita's own product literature for the D, HP 484, and DDF 484 explicitly advertises aluminum gear housing and all metal gear construction for extra high transmission durability. That phrasing is a buying signal. Makita is telling you which gearbox survives heat and torque. The DHP 485, the one with the polymer gearbox housing in the service manual, does not get that bullet point. Same brand, same battery platform, different transmission. You can still get locked into the battery ecosystem, but the tool body itself will outlast the plastic housed version under real load. The trade-off is weight and cost. Metal housings are heavier and often priced higher, but you are buying fewer tool bodies over a decade. Look for aluminum gear housing or all metal gears in the spec sheet. If the manufacturer does not say it, they did not build it. Number 1, buy Hilti and understand that you are not buying a tool, you are buying a service contract that happens to include a tool. Hilti offers a 20-year limited warranty plus 2 years of wear and tear coverage. That second part is critical. They cover parts, labor, and shipping for normal use damage. The not worth fixing calculation that kills every big box tool does not apply. When your Hilti drill needs work, you send it in. They fix it. They send it back. The repair cost is built into the upfront price, which is higher. The Hilti SID4-A22 impact driver lists at $185 for the bare tool. That is more than a DeWalt, but the DeWalt has a 3-year limited warranty. Hilti has 20 years plus service. Run the math over a decade. The DeWalt owner buys 2 or 3 tools and 5 or 6 battery packs. The Hilti owner buys 1 tool, uses the service program, and stays on the same platform. Hilti also offers fleet management, a subscription model where repairs are bundled into predictable costs. It is designed for contractors, but it is available to anyone who wants out of the replacement cycle. The trade-off is availability and ecosystem commitment. Hilti is not at Home Depot. You are buying into their platform, but you are buying into a platform that is contractually obligated to keep your tools running. Here is your rule. Check the gear housing, check the battery rules. If the spec sheet does not say aluminum gear housing or all metal gears, you are not buying a power tool. You are buying a heat-sensitive consumable with a firmware expiration date. Stop paying for the plastic. Buy the serviceable core. Subscribe because next week I am covering cordless yard tools, the same battery economics, the same thermal limits, and when they fail you are paying $200 for a pack, not fixing the trimmer. That one is even worse.